Welcome and hello. This is a video exercise in HEC RAS. And in this exercise, I'm going to be working with dredging, sediment dredging in a channel using a HEC RAS model. All right, so we're going to start from the very beginning here. I've got my HEC RAS open, version 6.6, but this should work in really any version, especially the newer ones. Go ahead and go File, New Project, and then go ahead and navigate to the location you want to save this HEC RAS dredging project. I'm going to call my project exercise 27, whatever you want to call it's fine, and then click OK. And then yes, accept the unit system for what we're using is US customary units. All right, first things first, I'm going to go ahead and define a geometry file and then a flow file, the sediment data, and then we'll get to the plan and the dredging. Go ahead and run some simulations, change a few things, and look at results to see how the input data affects the output results. Anyway, starting with clicking on River Reach, single left click at the upstream end of your reach and just start giving some clicks to add some curvature if you want. Double click at the end of the reach and then give that river and reach a name. River A, reach 1, okay, and cross sections. Let's start by going Options, Add New Cross Section. I'll start at River Station 0. That's going to be at the downstream end of the reach. And let's go ahead and add some station elevation data. So I'm highlighting those cells and pasting in some data I had saved in Excel on my other monitor that I had copied onto my clipboard. And then let's go ahead and say 0 distance downstream. And then, okay, so there's my Manning's N values I typed in. The overbank is 100 and 250. That's the station of the left overbank and right overbank, which you can see in the diagram here now that I click the apply data and am showing the cross section. All right, so here's 100, here's 250. Let's go ahead and add an upstream cross section at the very top of the reach and then do some interpolation for intermediate cross sections. So I'm going to copy the current cross section. I'm going to say this is at river station 10,000, click OK, and then also make 10,000 the distance downstream. And then I also want to add, we'll say 10 feet. So it's a very mild slope. It's a 0.1% slope and apply data. All right, so I'm going to close that. And then, like I said, I'm going to add some intermediate cross sections within the reach. I'm going to say this is going to take place every 500 feet and then interpolate and close. All right, so we have our cross section data right there. That looks good. All right, so let's save this geometry file, save geometry data. I'll just call this my base geometry file in case I come back to it and make changes later. Probably won't though. All right, so for the flow data, I'm going to go quasi unsteady flow data. And then what I'm going to do here for the downstream cross section is just go with normal depth. And then I need to type in that slope of the energy grade line. Okay. And then for the upstream boundary condition, I'm going to go with flow series. And then this is going to be a 1-month simulation. So I'm going to just go 1 day at a time. I'm going to say 24 hours. Computation increment will be 1 hour. And then the flow, I'll set it at 100 CFS. Okay, so these values here, I'm just going to copy. And then I'm going to come down here to day 32 or 33 and then paste. Okay, and then interpolate. So I've got all the data. It's just a constant 1,000 or 100 CFS. Very boring. That's not really the focus of this particular exercise. So I just want to kind of keep it easy to understand. So I entered the data, and then for this use simulation time, I'll just go ahead and do that. So the flow data starts at the beginning of the simulation. All right. Okay. Now I'm going to go File, save the quasi unsteady flow file, and I'm going to call this 100 CFS, and then click OK. Also, I need to specify the temperature data, so I'm going to just do the same thing. We'll say it's 55 degrees, copy. So that was 1 day at a time. Come down here to the end of the month. We'll just use the month of January, and then interpolate missing values. So it just basically copies all the values down, so that's easy. And OK. And then File and Save. Now it's time to add some sediment data. So if we go to our run, we have the base geometry file, our 100 CFS quasi unsteady flow file. Sediment data is next. So let's click on sediment here. Okay, so we have our river, our reach. I'm going to use just the default transport function, sorting method, fall velocity method, and so on. For the depth, let's go ahead and say it's 5 feet. And then for left and right station, I'm just going to use the bank station for movable bed. I need to copy this 5 down here for all the cross sections. So now I can see all the cross sections at once. The bed gradation, let's go ahead and define the bed gradation now. I'll call this grad 1, okay? And then for percent finer, what I'm going to do is paste in a gradation that I had saved in a file. So we have 0% finer, 100% finer, and then from the coarse sand all the way up to the very coarse gravel, we've got that data right there. Okay, so that's sort of the range of this gradation 1. All right, so let's see. I'm going to click OK there. I'm going to go ahead and assign gradation 1, and then just copy that down for all the cross sections. Simple enough. So that does it for our initial conditions and transport parameters tab. I also need to define boundary conditions for the sediment. So what I'm going to do here is click on this river station 10,000. This is at the top of the reach. And I'm going to define the rating curve. This is the flow load relationship. And again, I'm going to keep things simple with just two sets, two different flows. I'll go from a flow rate of 10 up to 1,000. And I'm going to keep the load exactly the same to keep it constant and easy to understand. Now for the gradation, this is going to be a much smaller gradation, which is typical for the flux load. And I'm just going to type in 20% for this range of class sizes from the fine silt all the way up to the fine sand. So clearly this probably isn't very realistic, but this is what I'm going with. Keep in mind that when you're defining this flux load for the rating curve of the boundary condition for sediment, you have to use the percent of the total mass. You can't use percent finer. It needs to be the percentage of that particular grain size. So this sums up to 100. I don't think you need to do that. I believe it normalizes on its own, but it's just kind of nice to see it sum up to 100 anyway. All right, so I'm going to go ahead and close that and then file, save the sediment data. I'm going to call this the base sediment data and click OK. All right, I think I have everything I need to now define the plan and set up the dredging. So I'm going to go up to Run and Quasi-Unsteady Analysis. This is used for the sediment. I have the geometry file, the one and only flow file, the one and only sediment file so far. And what I'm going to do here, I'm going to save this plan as 100 CFS, no dredge. Okay, so I'm going to run a plan first with no dredging just to make sure the model's working and we have some normal results, no errors. Then we'll add a dredging for a second plan and we'll call that dredging instead of no dredging. And okay, and then same thing here for the short ID. All right, so for the starting and end date time, I'm going to say this is during the month of January because it ends at the beginning of February. And I'll just turn on mixed flow. I don't think we're going to go super critical, but good to be safe. File, save plan, and compute. Okay, so that looks successful. I'm going to go ahead and just assume the results are fine. Let's go ahead and add a new plan with dredging since there's really nothing exciting about 100 CFS and no dredging. So file, I'm going to go save plan as, and then I'm just going to change this name from no dredge to dredging with 100 CFS. Okay, click OK. And then same thing for the short name. Okay. Now to actually define the dredging, I'm going to go up to options and then dredging events. The first thing I need to do is create a dredge event. So just click on the new dredge event, DREDGE 1 and OK. So here is my method. I'll use the left station, right station elevation right here. So to get an idea of where I want to dredge, let's go from 8,000 down to say 5,000. And I need to figure out what left and right station to use as well as what elevation to use. So I'm going to just look at the cross section real quick, come down here to 8,000. So the invert is 38. I believe that information's on the dredge page, but then the stationing from 150 to 200. Okay, I'm going to go ahead and just use those extents right there for the left and right station. All right, so anyway, back to the dredge editor here, dredge 1. I'm just going to go ahead and highlight the rows here for the left station from 8,000 down to 5,000 and then set that to 150. And then I'm going to do the same thing for the right station, except this value is going to be 200. And then for the elevation, I have the invert elevation of 38, and then it goes down to 35. Let's dredge 2 feet. So that makes this 36, and then this one down here would be 33. Now to fill in these intermediate values, I believe it's just a half a foot change, but I want to go ahead and use this little tool over here to demonstrate. So I'm going to set the upstream one to 8,000, the downstream to 5,000 right there, 36, and that's going to project downward from the upstream, which is 8,000 at a slope of 0.001. So that's the same as the bed slope. It'll be parallel. And if I click this button here, boom. All right, cool. So we got our values automatically populated. Now the start date of the dredge, I'm going to set that to the 3rd of January. So I'm going to let the simulation run a couple days, then the dredging, and then we'll see what happens after that. We'll have another like 4 weeks basically. I'll just say at the beginning. I'm going to say it's an instantaneous dredging. I know that's not realistic, but that's what happens when you leave off this optional dredge end date and time. We can go back and change that later if we want, but I'm just going to go ahead and save this or click OK. Okay, that closed everything, it looks like. Let me go back and make sure. Yes, we have a check mark next to dredge events. All the dredge information is there. All right, looking good. All right, so let's go ahead and run this 100 CFS dredging event by clicking compute. All right, so that looks successful. I'm going to go ahead and go close. Let's look at some results finally. View sediment output. Okay, I got the results page up right here. What I'm going to do is look at the invert. So invert elevation is right here. And I'm going to change this mode from time series to profile. So this is the invert elevation at the beginning of the simulation. Remember, the dredging doesn't happen until 2 days in, and these are all the different time steps I have to select down here. So the one that's selected is the very beginning of the simulation. I'm going to go ahead and scroll down to the time profile just before and after the dredging, because remember, this is an instantaneous dredging that's happening here. All right, so I believe this is just before and this is just after. Yep. All right, I'm going to change the color scheme right here. So blue is just after the dredging. Now this looks a little awkward because it actually goes up, but we can fix that. What I want to do is just check on a few more time steps later on in the month, later on in this simulation, and see what happens with the erosion and the deposition after this particular dredging event. Okay, so this is about a week later on January 10th, and I'll toggle that on. You can see the green line here now represents the invert, and there's definitely some deposition in this location where there was dredging just a week earlier. And then I'll toggle on the profile from 2 weeks after the dredging. That's right here in magenta. So you can see that's filling in, maybe about halfway filled in at this point. And then this is 3 weeks later in red, pretty much the same as 2 weeks later, it looks like. And then let me just go down to the very end of the month. This is light gray, kind of hard to see this color, but it's pretty much the same thing. So after 4 weeks after the dredging, it looks like it filled in about 2/3 or 75% of the original dredging. One thing I want to do to modify this is to fix this part down here. I don't want the invert to go up and then back down. I want it to basically remain constant at whatever elevation this is until it daylights to the original existing invert. So to do that, I'm going to go back to options, dredging events, and then 33 is the invert. So if I just copy 33 down to 33, which is this row right here, 33, 33, 33, 33. Okay, that looks good. And then I'll also just extend these numbers down as well. Okay, so I got those done. Let's go ahead and click OK. And then File, Save Plan. Let's go ahead and run that again. I'm just going to save over the existing plan. All right, close. And then let's go ahead and view sediment output. I'm going to look at the same data I was looking at before. So the mode will be profile. The variable, I'm going to use invert elevation again. Okay, so this looks the same. I'm going to toggle off that. Okay, so here's the original profile. Here's after dredging. That looks good. It looks a lot more natural. And keep in mind, this vertical scale is sort of exaggerated. It's zoomed in. I really could use a few more points upstream at higher elevations to make it look more flat, but this is very flat. Keep in mind, this is just a 0.1% slope. Let's go ahead and show the invert about a week, 2 weeks, 3 weeks, and 4 weeks again. Okay, so this right here in magenta is 1 week after the dredging. And then this right here, the red line, is 2 weeks after the dredging. And then this checkbox here, light gray, is 3 weeks after the dredging. And then about 4 weeks after the dredging is cyan. So it's about halfway filled in, it looks like. It looks like a much more normal shape than before. Of course, remember, it's not nearly as steep as it looks on this diagram. I want to do 2 more things in this exercise just to demonstrate some of the other options associated with dredging and sediment in general. The first thing I want to do is see if different gradation or a different flow, let's go with flow, will actually change the amount of sediment deposition after the dredging. So I'm going to close this. I'm going to go back to the quasi-unsteady flow data. Right now we're editing 100 CFS, but I'm going to pump that number up a little bit. So I'm going to go File, Save as quasi-unsteady flow. I'm going to change 100 to 300. Click OK. Okay, so it should be 300 up here, this label. I believe I'm editing the 300 file. Open. No, 300. Okay. Okay, now it says 300. I just want to make sure that I'm changing the right data. For flow series, I'm going to double click and then just type in a 300 here. This is going to be a constant 300. Again, I'm not going to get too fancy with hydrographs and changing flow rates or anything for this exercise. And then I'm going to interpolate the flows so all those are added in. Okay. File, save. Let's close that now. Now we have a new plan. This is going to be 300 CFS, but it's going to be with the same dredging, the same sediment, the same geometry file. Yes. Okay, so I'm going to go File, Save Plan. I'm going to click on this 100 CFS dredging, and then just so I don't have to type everything out, change the 1 to a 3. I like to highlight this, copy, because I know it's going to ask me about the short ID. I'll just use the same name there. Okay. All right, everything else is the same. It's going to be for the same month of January 2020. File, save plan, and compute. All right, looks good. Let's go view sediment output. I'm going to select the invert elevation for the variable. I'm going to select the profile, river A, reach 1. Okay, so this is the original invert just before the dredging. This is afterwards. Now let's go ahead and let's just zoom down to the very last entry. So this is like 4 weeks after the dredging. Ah, very nice. So the magenta line right here, we see a little bit of deposition, but far less deposition than we saw with 100 CFS flow, because remember, that's the only thing that we changed was that flow rate. It's a constant flow rate, and because it's higher flows, there's less deposition. It doesn't really matter what method we would use. Higher flows, if you triple the flows, you're definitely going to have more sediment transport and less deposition. All right, there's one more feature with the dredging that I wanted to demonstrate in this exercise, and that is the re-entrainment. So let's go back to our quasi-unsteady sediment transport analysis, options, dredging event, and it's this checkbox down here to reintroduce part of the dredged load. So I'll click that checkbox, and then what I want to do is say a percentage of the material that's dredged actually gets re-entrained and then redeposited downstream. Let's just go with 20%, or let's go with 30%. And then for, let's say there's no grain size threshold, but then we need to specify the cross section where it ends up. So I'll just go downstream to maybe river station 1500, and I'll click OK. All right, so everything else I'm going to leave the same. We're going to see what happens here. So I'll click OK as well. File, just save, and then compute. All right, so that's done. I'll click close. One more time on looking at the results for that invert. Here is the invert elevation. Then I'm going to change the mode here to profile once again. I'm going to toggle off the original profile. So this here is the invert just before the dredging, and then this is the invert just after the dredging. Okay, so this is probably one of the shortcomings of using instantaneous dredging is you also have instantaneous downstream deposition of that material. So this looks very unnatural, but we could actually see how this is going to erode as well. So let me do what I've done before and just toggle on a few more time periods. Okay, so just 24 hours after the dredging and this deposition, let's see, that would be this one right here. Okay, so it decreases a little bit, but not as much as I expected. Let's go ahead and advance down to the next week. Okay, so here we are 1 week later. That's the red line. And then let me just go down to the end of the simulation. This is after about 4 weeks later. Okay, I can't see that because it's the light gray color. Let me just click on the cyan. Okay, I still can't see that really well, but we can see that there is sediment buildup in the location where it was dredged. Obviously, a lot less with 300 CFS than with 100 CFS. And then the downstream location where that material that's been re-entrained gets redeposited. Very unnatural what's happening here, but cool that we could use the tools and demonstrate with this example with dredging in HEC RAS.